passband transmission. So in order for the wired transmission, the communication over these baseband frequencies are most appropriate. For example, the twisted K pair, the coaxial cable, or the fiber. So for these wire transmission, communication over baseband frequencies are mostly used. But when you go to wireless networks and the radio transmission, here we use a range of frequencies, because here they will not start with 0. Okay, so there will not be baseband frequencies here. For wireless channels, when you are using different frequencies, the antenna size will be different. Because if you are using very low frequency signals, the antenna size will be impractical to be made, because the antenna needs to be a fraction of the signal wavelength. Now, how do we prove it? Let us take an example, because the antenna size is of the idea of these frequency. So wavelength and frequency. Now let me tell you that which becomes large at higher frequencies. Okay. Now we have an example here. We have a frequency 15 kilohertz. Now with all the calculation, the lambda equal to C equal to n nu lambda and lambda by 4, the size of the antenna becomes 5 kilometers. So this is just to give you an idea that the 15 kilohertz frequency will want you to have an antenna of 5 kilometers. Even for the wires, when I'm talking about wire also, placing a signal in a particular frequency band is useful, because that will allow different kind of signals that can coexist in the channel. Passband transmission. So passband transmission is all about arbitrary band of frequencies, different bands of frequencies. Band means the range of frequencies which is used to pass the signal. So the frequency band can be anything. This can be a band, this can be a band. So that is why we are saying arbitrary different band of frequencies which are used to pass the signal. This is the passband transmission. It is a range. It means arbitrary band means different band, different frequencies and different range. These are used to pass the signal. So what we can do is, the best way is to take a baseband signal. We know that it goes from 0 to some B hertz. B is the bandwidth, and you can shift it up to you can shift it to S, shift by S. So when you shift it by S, the passband of S, that is, it will become, now when you shift it from S, just add S. So S till S plus B, it will, because you are not changing the amount of information it can carry. You just shifted this baseband signal. But the signal might look different. What will happen at the receiver end? We can shift this back. What we have shifted to S plus B, again we can shift it back to B. That is, again to 0 to B. Back to the baseband. And in this baseband, it is more convenient to detect the signals. It is very easy and convenient to detect signals. That is why we are shifting it back. This can be done. So the digital modulation, because in passband transmission, that is digital modulation is accomplished with this passband transmission by modulating the carrier signal that sits in the passband. So the modulation is all about bits to signals and signals or to bits to analog signals and then back. So we can modulate or change the carrier signal that sits in this passband. This is how passband transmission, digital modulation is done. So what I am trying to suggest here is, we can modulate either the amplitude, the frequency or the phase of the carrier signal. These are all the properties of any wave, carrier signal. So the amplitude change, frequency change or phase change or variation, this can be employed for actual digital modulation, right?